EDEXCEL IAL, Mathematics P1, Pure Math 1 from June 2022. Question 5 deals with functions and inequalities between the functions. Let's take a look. Question 5, the curve C has the equation y equals fx. Okay, fx is a quadratic expression. So f of x, maximum turning point of C, so it has minus 212. And C cuts the x-axis at negative 5. So it cuts the x-axis at negative 5. So it's going to cut some sort of x-axis here. Negative 5. Okay. Either there or there. Find what f of x is. So question 5a wants an equation for the function f of x. Right, let's take a look. So we have this information that's quadratic. So quadratic looks like this: ax squared plus bx plus c. That is a quadratic function standard form. And c, we know what's that c, which is the turning point, is minus 2 and 12. And this is a maximum turning point. So, okay. And then C cuts we know that the x-intercept is, or an x-intercept is going to be minus 5, 0. One of the x-intercepts. Okay. So all of this information we can use to figure out our equation of f of x. Well, let's first look at the maximum turning point. So it's min-max of any equation. The first derivative is going to be equal to 0. And the reason for this is because the first derivative is the gradient of the curve. Gradient of the function. Okay, so why is it 0? Well, because the gradient of this line here, the tangent at this point is 0. The gradient here is 0. Okay, so that's the reason that f dash of x equals to 0. So we can straight away assume that f dash of x equals to 0. First thing, find some sort of formula for f dash of x. Well, f dash of x can be taken from our f of x that we made, knowing that it's quadratic. So f dash of x, you take, if you have a times x to the power of n, then it's, if that was your f of x, then f dash of x would be n a x, and then after that you do n minus 1. Okay, in that order. Good. So let's take a look. So 2 times a is 2a. 2ax, 2 minus 1, x to the power of 2 minus 1 is just 1. Bx to the power of 1, doing this one, is, well, just b times 1, which is b. x1 minus 1 is x to the power of 0. So just b. X to the power of 0 is 1. Okay. Here's our f dash of x. And we know that when our f dash of x equals to 0, so here's our f dash of x formula. We know that when our f dash of x equals to 0, then the x value is going to be minus 2 from our turning point over here. So if you look at our turning point that was given, the x is minus 2. It was given to us. So therefore, we know that the x value here is going to be f dash of minus 2. is equal to, oh, f dash of minus 2, 2a minus 2 plus b must be equal to 0. Right, so minus 2 times 2 is minus 4. Minus 4a plus b is equal to 0. So we have only two unknowns here. So let's call this equation 1. We've used some of our information. We need to solve for a, b, and c, all our unknowns. Okay, what else do we know? Well, the turning point is a point on the graph. So if we had a, just for the record, I don't know if it's this way or this way, just drawing the sketch. The only reason I drew it this way is because it said it had a maximum point. So that's why, yeah, maximum. So I'm assuming it's going to be this way around, but it could be either. So let's look at this one. So this maximum point was minus 2, 12. And that is actually a point on the graph. It's a point on the f dash of x, but it's also a point on f of x. So we can say in our working that f of negative 2 is equal to 12, just like f dash of negative 2 was equal to 0. Okay, so let's do this working. Our f dash of x, wherever our f of x was ax squared plus bx plus c. So wherever we see the x's, we can interchange them for negative 2. So f of negative 2, a negative 2 squared plus b negative 2 plus c must be equal to 12. That was the y at point negative 2x. Okay. So here we have negative 2 times 2 is 4a. Negative 2 times b is negative 2b plus c equals to 12. Let's call that equation 2. So we have another equation here. What other information did they give us? Well, they gave us the x-intercept, and that gave us negative 5, 0 as a point on the graph as well. So we can also do f of negative 5 must be equal to 0. F of negative 5 must be equal to 0. So let's call that, this will be equation 3. So let's quickly do it out. F of negative 5, a times negative 5 squared plus b times negative 5 plus c equals to 12. Right. Negative 5 squared is 25. So it's 25a minus 5b plus c is equal to 12. Okay. Let's call that equation number 3. Right, so now we have 3 equations, and just to show you what I'm doing for the ABCD method, I'm going to copy all these equations down. There's one. Usually you wouldn't need to do this in the proof. Number 2. Go, and number 3. Okay. So if we have 3 unknowns, you need 3 equations. So we had A, B, and C. So we needed we needed what is A, what is B, and what is C. So the first thing I did was I just took all the information that was given and I made equations out of it using the words, and I put them in math. Okay, so let's look at number 1. If we rearrange number 1 slightly by plussing 4a on both sides, then b will be equal to 4a. Let's call that number 4, okay, just to follow on. So if b is equal to 4a, we have an actual value for B that we can use. And then if using the same logic, we take number 2 and we isolate C, we make C the subject. So we minus 4A and we plus 2B. So C will be equal to 12 minus 4A and plus 2B. Using this exact same logic, let's call this number 5. We can do that with equation number 3. So C will be equal to 12 minus 25A plus 5B. Wait, there wasn't, this shouldn't be 12, this should be 0. Something's going on. Hang on. This 0, oh, here we go. Here's my error. That wasn't equal to 12 at all. This was equal to 0. There we go. Good. Self-check. Very helpful when it happens and not so fun when it doesn't happen. There we go. So this, just carrying on my self-checking, this particular C is just going to be minus 25 because the 0. Okay. Excellent. So we have a number 6 over here. Now we can start solving for things. So the first thing I'm going to do is I'm going to let C equal C here. So I'm going to let my equation 5 equal to equation 6. Okay. So 12 minus 4A plus 2B is equal to minus 25A plus 5B. Let's get add like terms. So plus 25 on both sides. And we end up with plusing 25A. And we can also minus 2B minus 2B on that side. Okay, let's see what happens. So plus 25A, but still got the 12 there. We plus 25A and we get minus 4 plus 25 is plus 21A. And if we minus the 2B, then we get equal to 5 minus 2, which is 3B. Last step is you choose something to be on its own. Or this, I'm going to choose the B because it's already almost there. So we can say that if we divide both sides by 3, our B, that side cancels out, equals to 21A plus 12 all over B. And this I'm going to call, just to keep track of everything, equation number 7. Okay, so now we only have A and B as our, that was a 3. We only have A and B as our unknowns. We're getting there. So we can go back and grab an equation from the beginning. Yeah, we had number 1. We had number 1 here. That was good. Number 1, 2, 3. We rearranged number 1, so number 4. Number 4 is a good one. We had another value for B. B equals 4A. Okay. So we know that B equals 21A plus 12 over 3, but it also equals 4A. So let's let number 4 equal to number 7. So 21A plus 12 all over 3 must be equal to 4A. Right, so now we only have A. We can finish at least getting A. Okay, how do we do this? Well, 21A over 3, splitting the denominators, plus 12 over 3 is equal to, we times this by 3 over 3 to get the denominators all the same. 4 times 3 is 12 over 3. Right, drop the denominators, get 21A plus 12 is 4 times 3 over 3. Why didn't this work? Ah, there's a missing A. Okay. It's 12A. Bring all the A's to one side. 21 minus 12 is minus 10 is 11. So we get 9 minus 12A minus 12A. Okay. 9A is equal to minus 12. And minus 12 from both sides. Last step, want A on its own, divide by 9, divide by 9. A gets to being minus 4/3. Right, we finally have one of them. We only have one of them. A is minus 4/3. When we sub into an equation that only had B in. So we had this one. I think it was equation 4. Yes, equation 4. B equals 4A. So sub into equation 4. And B equals 4 times minus 4/3. So we have now B, which will be 4 times minus 4/3 is negative 16. Top times top, bottom times bottom, negative 16/3. Okay, now we've got A and B. So we have actual values for A and an actual value for B. And we want to sub these into something that has a C in. Okay, so where we find something with C, well, we can choose equation number 5. Equation number 5. Oh, wrong tool. 12 minus 4A plus 2B. Oh, actually, that one has an unknown. I'm going to choose number 6. 25A plus 5B. Okay, negative 25A plus 5B. And this was equation 6. So sub into 6. So we know our A value. Our A value is minus 4/3. So C equals minus 25 times our A value, minus 4/3, plus 5 times our B value, which we know is minus 16/3. Okay. Put this all in the calculator. We can do it by hand. No restrictions here. And I get 20/3 as my C. Here's just the equation asked for you to write it out. So we want the actual equation. We can't just leave it like this. So we had, remember it was ax squared plus bx plus c for quadratics. So our A value is negative 4/3. And our B value is negative 16/3. And our C value is 20/3. And we are done. All right. Some more information is given. Line L1 has the equation y equals 4/5x. Given that L2 is perpendicular to L1 and passes through this point minus 5, 0. Write an equation for L2 and write your answer in standard form. Okay. So if you have L1 and L2 as perpendicular to each other, that means that m of L1 times by m of L2 is going to be equal to minus 1. That is the gradients. That's okay. Gradients. Okay. So what does that mean? Well, we have L1. This is number B. And it's in the form y equals mx plus c already. And that form is y equals 4 over 5x plus 0. Obviously, the c value is 0. And it's perpendicular, which means the gradients m times m1 times m2 is going to equal to -1. So in the short form, well, it's just that your new gradient of L2, you flip the 4 over 5 over and you change the sign. So it'd be 5 over 4. But if you want to do the actual working to show it on your answers, then you do, well, 4 over 5 times by the gradient of L2 must be equal to -1. So we divide both of these by 4 over 5. And because of tip and times, the gradient of our line L2 is going to be -1 times by 5 and 4. And that's -5 over 4, which we got quickly if you just turn it over and change the sign. Okay. So we know the gradient. And then it was given that it passes through the point -5, 0. So we just sub -5, 0 into our formula. And so far our formula was y equals -5 over 4x plus c. Let's sub -5, 0. So we get 0 is equal to -5 over 4, and where x is -5 plus c. Okay, y is 0 and x is -5 on that point. And so we can times this out and take it over to the other side. This would become positive. So c, this was negative times a -5. So we just have 5 times 5 over 4 and negative again. Take it over the other side of the graph and we get 25 over 4. Okay. So final answer, y is equal to -5 over 4x minus 25 over 4. Good. Okay, question C. It wants us to define region R. So here's our, in this figure, figure 2, move that a little in. There we go. So here's our curve line, C. And that's going to be here on the diagram. Then I've brought forward also L1. Okay, and L2. L1 and L2. We have all our information here. So we want the area that is in between all of this, R1. So we want the area inside here, the region, not the area, they want to know the region in between these three functions. Okay. Well, first we look at the curve. So the curve is at the top. So we know that our y values have to be below the curve. It says using inequalities. So we know that our y value, y must be underneath the curve. And because the curve was a solid line, we also say equal to. Okay, so we just write down the curve here. That's our first part of the answer. Then the second part of the inequalities is we're looking at L1 and L2. Well, if you take a look at L1, it's above L1. So we know that y needs to be above L1. And it's also a solid line, so equal to. And if you look at L2, same thing. The area is above L2. The area encased the R1. Okay. -5 over 4x minus 25 over 4. And that's it. That's all they're asking for. And that concludes question 5. Fantastic.